vents, okay? There's some fans that'll blow, and this is at nighttime, so remember there's a three-phase process.
Right.
The absorption phase at night will bring the air in, and it will run that air across the desiccant stacks. Up, 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 and then ultimately right out these fans and out the side. And this absorption cycle will happen over and over and over. And again, in Florida, there is maybe 2 or 3 hours at nighttime if you're on the solar. If you're plugged in, it'll go until it reaches saturation. But it will go no matter what until it reaches saturation. Come saturation point, and again, the onboard systems have all the necessary metrics. Come saturation point, this intake line comes from the solar, the thermal heating. So it's going to heat the fluid that's in there. And that fluid heats what this metal bar underneath here, which is essentially a radiator. It's like a car radiator, and that generates the heat, which is blown across the desiccant stack. And there's a hose back here that will ultimately feed the hot air right back into it. So this is a closed circuit like this. These vents will close, and that closed circuit will circulate the air around and around and around until it reaches a certain density of humidity. It's got all the humidity in there. Now the moisture's there. And once the onboard control systems recognize that the moisture is there, it will take it out here into the condenser and return it back to the stack. And it will keep extracting the same air, the humidity from the same air, until there's no more, in which case it'll start the cycle again of heating it up and extracting more and more and more until it's reached the humidity point and then extract it out. What ends up with the condenser in the back, if we walk around the side of the unit, the condenser in the back drops droplets of water into a receiving bucket, which we have shamelessly taken from Brita. And what you are looking at is Dallas Air. This is essentially pure distilled water. This is an overrun, right? So when it overflows, it'll come through. Computer system for the control systems. Now, the solar panels will charge an onboard battery, so it's used at nighttime. And anytime one of these fan systems comes on, there's an intelligent controller on the inside that says, where am I going to get the greatest voltage? Is it from the battery, because there's no sun, or is it from the solar panels, because there's plenty of sunshine? So it knows how to select its own source autonomously of the power. So step one, phase one, absorption. Phase two closes those vents, and there's an internal circuit that heats it up and gets the air humid. The second half of phase two is to extract it by once it reaches that critical density of humidity through the condenser, and out you have water. What we do with it next is this. We take the water, please watch your step over the cables. We take the water, and of course all of this will be embedded in the system itself on the final unit. The container of water, and we run it through, and no, this looks very threatening, it's not, although taking it through an airport has proven to be challenging. But we take the water and we run it through the pre-carbon filter, we run it through the UF membrane, and we run it through the mineral carbon filter as well. And so what you'll end up with
there's also UV, did you mention UV?
Oh yes, I'm sorry. There's also a UV light that hits it to make sure that you end up with bacteria-free, precisely.
And that was getting the first bottle.
Well, so the first bottle, I can tell you, because it's been sitting out here, is a little bit warm. But what I can do is provide you the ones that I bottled this morning, which was nice enough to put on ice for you. Compliments.